Let's learn how to use Maya's normal constraint. The normal constraint causes an object's orientation to point at a surface or mesh, so we can use this for both NURBS and polys. And what we'll do is create a better brow rig with this tool, one that causes the brow to appear to slide across the surface of our character's skull. So in order to have this happen, if we were to go ahead and hide the character viz layer, what you'll find in the scene is a NURBS patch. The reason why I'm using NURBS is because it's a little bit smoother than using a poly surface. We'll find that if we normal constraint to a poly surface, especially one that is low res, we might get a little bit of popping in our constraint object's orientation. Again, so it's a little bit safer to work with NURBS. Now this NURBS patch, just to take a look at this, if we were to select it and hit the up arrow, you'll find that it has been parented to the head bone, just to make sure that this rig will function properly. So we'll always want that patch to follow the character's head, of course. We'll need to make sure that as the constraint takes the object's orientation along the surface, that there is no twisting as well as what we would run into naturally without some type of solution. So we'll take a look at those options to make sure that this rig is going to work to our advantage. Alright, so let's say we go ahead and get started. I'll template the brow patch layer. And at this point, what we'll do is create a locator. This is going to be our up object. We're not going to use it just yet, but we're just going to go ahead and put it in place just so we could see why we'd want to use this object. So I'll just go ahead and translate this up. I'll parent it to the head end joint, just to make sure, again, it's tied to our rig. And we can go ahead and call this LOC up VCT01. Okay, so there is our up vector. Alright, so now at this point, let's go ahead and template our character viz layer. We'll go ahead and make selectable our NURBS patch. And we'll start with our first brow joint on the left side. Alright, so with the surface selected, we'll now want to shift select our brow joint, BNL brow A. Underneath animation, we'll choose constraint, normal, and take a look at the options. Alright, let's reset our settings. I'm just going to go ahead and work with the settings by default. So you can see that the joint is flipped based off of our normal constraint settings. You can see right now the x-axis is what would be pointing at our surface. That's what we have that set to. So you can see how our joint has been rotated again to accommodate these settings. Watch this. As we grab the joint and start to move it, you'll see that it will be oriented to the surface, but we can also run into some very bad twisting when we get to a certain point. So you can see here, as we start to leave that surface, get a little bit of twisting, which is not good at all, especially as the character's head starts to rotate. If we were to grab the head control and start to just rotate that around, you'll see that our joint is prone to twist, again because there's no way to lock the twist down currently, so we'll need to go ahead and take care of that. Alright, so that's what we get by default with the normal constraint. Let's say we start to tweak a few of these settings to get something that's going to work for us. Alright, so I'll go ahead and just remove the constraint from our brow joint. We can move over to our outliner, press the F key to quickly find that object, and just go ahead and delete the normal constraint, which was nested underneath. Okay, so at this point with the joint selected, let's go ahead and zero out its transforms to bring it back to its bind pose, where it was originally. And now let's go ahead and take a look at our settings and figure out what we would need to use. So we know that our joint currently has the Z pointing at the surface. So instead of a +1 in our aim vector in the x-axis, we'd need to use a positive 1 in the z-axis. So let's go ahead and now zero out the x-axis. All right, how about our up vector? Well, we know that that is positive y, so we'll leave the up vector value the same. But now we need to use an object to control the up vector's twist. So let's say we go to our world up type and switch this to object up. If you'd like to learn more about this menu, by the way, feel free to take a look at our aim constraint lesson. All right, but I'm going to go ahead and set this to object up. Now we need to define what object is our up object. Well, that's going to be, of course, our locator. So we could always grab that, grab its name from the channel box just to make sure there are no spelling errors. We'll go ahead and paste that in. And now watch this. Let's grab our surface. We'll grab our joint next and choose apply. You can see we get a much better result now. You can see the Z is pointing properly and so is the Y. And watch this. As we start to take this joint and move this along the surface, we don't run into those twisting problems as we did before. So that's really exciting stuff. Okay, so I'll go ahead and take the joint and zero out its position. We won't want to interfere with rotation at all because it is locked down by the constraint. However, you can animate on top of your constraint channels. If you'd like to learn more about that, feel free to take a look at our parent constraint tutorial in this reference library series. All right, so once that has been created, what I like to do from here is go ahead and take the rotate channels, right click, and just go ahead and lock those down. Okay, great. So let's say we go ahead and take care of the rest of the joints, and we'll see the benefit of working with this when we go ahead and quickly skin these to our character's brow. All right, so again, we grab our surface, we grab the next joint. We're still using the same up vector node and the same settings, so we'll go ahead and choose apply. And then at this point, we'll want to test this out, so we can grab our joint and start to move that along the surface. It's exactly what we want. Really exciting stuff. All right, so at this point, we'll go ahead and lock down the rotate channels here. We'll need to do this one more time for our last control or our last joint that will influence this brow. All right, so again, we grab our surface, grab the joint, apply the constraint. Great. All right, we can now test things out. Just make sure everything's working properly. All right. Okay, at this point, we'll go in and lock down rotation. Okay, so let's see what this does to our character's skin. I'll go ahead and make the character's mesh selectable, and I'll also template our brow patch. Grabbing the watchman's face, we'll now go in and shift select our brow joints, only the ones on the left side. The right side has already been taken care of. Now we'll head over to skin. We'll choose edit smooth skin, add influence, just go into the options, resetting the settings. We'll turn off use geometry, and lock weights will turn on, so none of our weight values shift, and we'll choose add. I'll grab the surface, and then we'll head over to skin, edit smooth skin, to our paint skin weights tool, just so we can go ahead and unlock the influences we've just added. So that's brow A, B, and C on the left side. We'll just go ahead and choose unlock. We don't have to worry about weight painting at all. We just need to transfer our weights over since the right side has already been taken care of. So selecting our character's face, it's just a matter of heading back over to edit smooth skin, mirror skin weights. Taking a look at the options, we'll want to mirror from negative to positive. So we'll go ahead and uncheck the direction option and choose apply. All right, so let's go ahead and take a look at this. Go ahead and close out the menu here. So here's how the joint would behave without the normal constraint. You can see what we get is very linear. So this would still work, but it would require a little bit more work in that we'd have to go in and start to rotate things. Rotate our joints to to do what the normal constraint would naturally do. So you could see, taking a look at the topology of our character's face, how the joint naturally rotates. So again, this is a great idea for simulating the brow sliding across the skull. We'll take a look at another technique of doing something like this, but something that will give us a result that's a bit more precise when we discuss the tangent constraint. But this is a really neat rig to use. You can see that, of course, rotation is locked down, but there are ways of getting over that hump by a little bit more setup in this brow rig. If you'd like to learn more about that, feel free to take a look at our Rigging Human Faces course to learn more techniques for rigging a face for animation. But let's look at working with Maya's normal constraint.